Thank you so much, Junko and Lawrence, and too kind. I don't think I get all that credit, but yes. Right. So let me start my talk by just to give you a bit of a context. Oh, I just realized that's in an annoying spot. I'll put it here. Right. So the first millennium BC in Japan is a kind of a pivotal moment. It's if there is one point in Japanese prehistory where everything changes, it's that millennium. It's a age of intensification with contacts with mainland Asia. This is something that happened before as well, but during those 1,000 years that in following few centuries, this increase of interaction led to major transformation in Japanese archipelago. It led to the introduction of intensive farming. You can see this is a picture of a recent excavation, one of the largest Yayoi paddy field sites that has been found in Nakanishi site. The early Yayoi paddy field. It's just gigantic. It led to the introduction of metallurgy, and early states chiefdom started also in this first millennium. So it's a key moment. It's also a key moment also from a biological standpoint. Much of the modern Japanese population owed to that mixture event that followed at the start of the first millennium BC. The Yayoi period, which represents the first millennium, is not the moment with the highest amount of progression. There's a recent paper by Cook which shows that the admixture event happening in the Kofun period later on is actually larger, but it is a start. It is a key starting point where this admixture event with migrant communities from mainland Asia started to actually interbred with the local incumbent population of hunter-gatherers and led to what constitutes the current Japanese population. So much that if we look at genetics of modern Japan, we can still see the traces of that admixture event. You can see clines of variation across the Japanese island that reflect not just in northern Japan and in the Ryukyu Island, where we have really different populations, but even within the main 4 islands of the Japanese archipelago, we see still this variation in the genetics. And that beginning, the start point of that geographic variation and genetic variation goes back to those events that occurred during this first millennium BC. It's also a moment of linguistic changes. There's a recent paper by Roberts et al. That traces the origin of the Japanese language as part of the group of Trans-Eurasian languages. And so the Japonic language itself is something that is a consequence of that migratory event during the first millennium BC. Archaeologically, usually I start from this way, but I wanted to put this at the end. It represents the end of the so-called Jomon period, for over multiple 1,000 years, and the start of the Yayoi period. And I just choose the Jomon pottery and Yayoi pottery because I think it's emblematic of how different stylistically, visually they represent very distinct moment in space. This dichotomy, though, this idea of Jomon versus Yayoi, is a very strong influences even in modern day society. And this idea of this sort of a dichotomous nature of Japan being Jomon versus Yayoi. These are some fun slides from the internet. You can see the Virgin Yayoi versus the Shak Jomon. This is actually from an exhibition in I think it was in the in the National Museum of Japan, where they put Jomon and Yayoi as contrasting alternatives, right? So you have the Jomon girl fighting against the Yayoi girl because they represent 2 different moments in Japan. It has also implications in terms, because the morphology, the skeletal morphology of Jomon groups and basically the of a Yayoi individual is so distinct that led to also interesting things. So you can see celebrities who look more like Jomon and who look more like Yayoi. You can upload your picture and see whether you are more Jomon or more Yayoi. Apparently, I'm 75% Jomon, which is, I think it's quite right in terms of, I feel like I'm more Jomon. You can see magazines where how to distinguish Jomon faces and Yayoi faces. So, which ones are more handsome? Lots of interesting things, and this is stemming from this morphological differences between Jomon and Yayoi. This is an interesting one. This is an art historian, Yamashita Ryuji, who describe the history of Japanese art as an alternation between period of Jomon-like art, flamboyant art like this chicken by Toyakushu, the period where you have more calm, more subtle art represented by Hasegato. This is not just in art history. The latest I found, which was the funniest one, is business, right? So you have Jomon kind of business versus Yayoi type of business. So Jomon is more instinctive, collaborative, based on freedom, while Yayoi is much more organized, competitive, compliance. It's so you can. The suggestion here is that we should embrace Jomon kind of business. So really, there is this idea of black and white, red and blue, whatever color combination you want, of this contrasting idea of Jomon and Yayoi. And as anything that has this sort of a binary perspective, the reality, of course, is never like that. And in fact, there's a complexity in defining what is indeed what is Yayoi culture. And there's been attempts to describe and try to define Yayoi. You can see in the literature different definitions depending on which elements to pick up. And the reason why it's difficult is that the elements of Yayoi culture are actually very different depending on when and where we're looking at. Yayoi period is an age of transformation. That transformation doesn't happen in a moment. It takes multiple centuries, nearly a millennium, and it happens in a very different way in different parts of Japan. So Fujio Shinichi tries to describe Japan as being characterized by there's a middle culture where you have the most emblematic case of Yayoi, of the element of Yayoi packaging displays, but there's also a southern blur. I don't know how to translate Bokashi. I can use blur, but it's a sort of a periphery transitional state in southern Kyushu and also in northern Japan. And of course, we have the northern culture, which later becomes the Jomon, Satsumon, and Ainu culture, and the southern culture represented by Ryu. Even within the middle culture, we actually see variation. It's not something homogeneous. And trying even to make a chronological diagram representing when the Yayoi period starts and when it ends, it's tricky. So you have attempts like this where each sub-region of Japan has different starting point, and the starting point doesn't necessarily mean that they have a matched number of cultural elements being displayed in each of these regions. Sometimes certain elements get transmitted and start earlier, sometimes certain elements don't get transmitted, and sometimes you have reversion of other elements coming first and then after. So it is a rather complex image, and so there is not such a thing as a Yayoi culture. There are Yayoi cultures, and each one of them have its own characteristics. Now, this divergent responses of hunter-gatherers and local incumbent population in reaction to migrant communities, not, of course, unique to Japan. We see this in many other parts of the world. I just cherry-picked some quotes and some papers showing ideas of coexistence, of hybridization, resistance. All these are ideas that we see increasingly in the archaeological record in different parts of the world. So, but why then look into Japan? And I think there's an opportunity that is what makes Japan particularly special. What makes special to me is that, first, from an environmental standpoint, in a relatively small space, I mean, Japan is very large, but it's relatively manageable space, you see a huge variation in climate. Japan has a huge latitudinal spread. So if we do include Okinawa, we have everything from Miami to Boston, right? These are not necessarily pictures taken the same day, but you have these kind of different climatic environments. So it is a great opportunity to see how different ecological settings have an impact on the adoption of farming. And the advantages of studying in a single country means that we have the same kind of sampling strategy, archaeological research tradition that enable us to basically unpick these different factors in a controlled environment, let's say. Another good reason why it's worth exploring this in Japan is the sheer amount of archaeological data available. The graph on the top left here is the number of rescue excavation in Japan, and I think there's many versions. This is the latest one I found. I think Junko, you published something a few years ago, and as you can see, since the mid-19 onwards, it's the number of rescue excavations nearly about 8,000 per year. This one, which I forgot the reference, this is actually from a tweet by one of the scholars working in the Nara National Research Institute. I don't know if you can see this, but these are actually site distribution in the Tokyo Bay Area. Each of these tiny dots are different sites. There's no background map. It's just the site itself is sufficiently dense to show the shape of the Kanto region. It also shows how there's discrepancy in research. So all these mountains have much less intensity, but it shows you how much data there is. And increasingly, these data are becoming available also in a digital format. There are databases being generated. There's a radiocarbon database, has nearly 45,000 radiocarbon entries, which again, considering the size of Japan, it's quite impressive. There's a plant macrofossil database, site reports being digitized. So there's an increasing translation to all of this effort into a digital format that is more easily accessible than before. So we thought that this was a great opportunity. And 2 years ago, we started this project, Encounter project, that is funded by the European Research Council. And really the objective of the project is to look back at everything that is available, all this legacy data, and then reevaluate many of the hypotheses that have been made by Japanese archaeologists. How many of them are still robust to the evidence? Once we aggregate all this, how many needs to be reconsidered? What kind of adjustment we need to take into account? So much of our work is based on published record and trying to make sense and putting these different data sets and apply a different kind of statistical technique. My main expertise is in computational statistical analysis. So much of this work is based on this analysis of legacy data. So synthetic research data use and provide also an open source, an open science research framework so that these methodology can be reutilized in different contexts. There are other elements. Oliver Craig and Jasmine Lundy from the University of York, they're doing actually organic residue analysis on pottery that are the final Jomon to middle Yayoi. So there's also some new data that are being collected by the project, but the predominant mode and focus is actually on the synthetic data. And just a few note, this is something I never had a chance to say anything about. The logo of the project is actually, this is very niche. It's actually a Yayoi period dogu. So dogu are known of representing the sort of the emblematic artistic achievement of Jomon period, but they are Yayoi period dogu. And so I thought this was the best way to represent the idea of the project is that it's not as simple. It's not necessarily you see also the two shadow sort of representing and discussing this sort of a binary idea. So what I wanted to talk today about, this was a whole preamble, is to focus on one particular work package that is specifically looking at the adoption of rice and millet farming in Japan. So this is a work package that I've been working with Chris Stevens, who's an archaeobotanist, and Shinya Shoda, who's an archaeological scientist. And we wanted to look into from a botanical standpoint, what was the process of this adoption of rice farming across Japan? Now, why modeling the dispersal rice farming? Why there's a need to look at this? Why look again at about the tempo, about the arrival dates? The problem is that there's no real consensus other than rice started in northern Kyushu here and dispersed along Japan and along the Japanese island with different episodes of the day. If we look at different publications, they all provide different narratives, different dates. Some of them are in agreement. Some of them suggest very controversial this idea, for example, that actually rice farming started in central Japan, not in northern Kyushu. Some people put delays in certain regions, others put delays in other regions. So there's a lack of consensus, right? Partly this comes from the fact that many of these analyses is using mixed form of evidence. So some of these are using charred rice states, so very precise and accurate dating. Some of them are mixing rice states with pottery typology. In some cases, we rely only on pottery, assuming that pottery and rice travel together, which is a data assumption. So if you assume you find pottery, that doesn't necessarily mean that rice was there. Many of them are descriptive rather than inferential. So earliest state of rice in a particular region is not the arrival point of rice in that region. Arrival point is earlier than the earliest state. So we have to account for how many samples we have, how much earlier this was. There's no actual estimate on the speed of the dispersal process, which is something that has been analyzed in other parts of the world. So there's no comparative ground on how fast rice travel. And as I said, there's a minimal account of chronological and sampling uncertainty. So that led to effectively different narratives and different explanatory models. Now, Yayoi chronology itself is something controversial. So if you go on the website of the British Museum, embarrassingly, Yayoi period starts on the 3rd century BC, because until not that recently, till early 2000, that was the start date of Yayoi period and rice farming in Japan. In the early 2000s, there was a series of studies that showed that actually rice arrived 500 years or even more earlier. And that led to a huge ripple effect within Japanese archaeology on everything had to be narrated differently because, of course, Yayoi period was 600 years and then suddenly it becomes twice the length. So everything that appeared fast, now it's slow. The timing were all offset and led to a huge discussion. And even now, it's extremely hard to pinpoint the precise date on when Yayoi period starts because there are, again, multiple definitions. I personally think that being obsessed about these definitions is a bit silly because ultimately it's just semantics and what we want to describe is the general period. So usually I say first millennium BC, so I'm generic enough. But it has led to major debates about the start date. And much of this comes from the fact of which dates we can trust and which dates we cannot trust. A lot of benefits stemming from Japanese archaeology is that pottery was available before the arrival of farming. So Jomon period is renowned for its pottery, and pottery, from a chronological standpoint, it's an impressive tool that we have in order to date sites of which we don't have, say, radiocarbon dates. It's great to build relative chronology and sequences, but once we start to examine things that are related to absolute chronology, so once we try to assess speed, once we try to assess contemporaneity, translating this relative chronology to absolute chronology is important. And the problem is that, again, there are inconsistency and disagreement from this standpoint. Some of them are few years apart, like 50 years, and might not have a huge consequence, but others have major discrepancies in terms of how we date things. And much of these chronology are also based on mainly visual inspection of radiocarbon dates from pottery. Now, there's a few sorts of problem there. First, dates from pottery are tricky because if it's soot, there might be old wood effects. If it's organic content, depending on what you're cooking, might have huge implications, so you might have reservoir effects. So accounting for these factors is itself already a problem. Unless you're not lucky and you find a seed embedded in a pot, which is something that people are starting to look at, but the number of dates that are of that quality are relatively rare. And the second issue is, of course, the chronological uncertainty. So this is just one example. I used a data set that was published that suggested these chronologies and applied a very simple Bayesian model to estimate the start and end. And what you can see is there's much more uncertainty than how it's being displayed. So we don't have that much resolution. We don't have evidence to say anything that narrow. And so these pottery styles might be contemporary. It's hard to pinpoint start and end. All of that uncertainty needs to be accounted for once we, if we want to try to build this something more robust. So there's a problem of overconfidence on ceramic chronology. The other problem, and this is everything interesting happens when there's a calibration plateau, right? All things interesting. So, of course, the whole spread of Yayoi period matches exactly the calibration plateau around 2,500 C14. So the initial Yayoi, which is the arrival point of rice farming, is around here, and the whole spread happens where the calibration plateau is. And not accounting for the calibration plateau has major implications. I'll come back to this point in terms of how we calculate, for example, rate of dispersal. Actually, now I'll talk about rate of dispersal. So one of the other issues is this assumption that the spread is, of course, homogeneous. And spread, of course, might have different speeds. And you might have local episodes of delay, local episodes of acceleration. And much of the European literature, for example, in this regard, try to infer whether the variation in speed is actually a proxy to infer differences between endemic versus cultural diffusion. I found this a bit problematic. The idea fundamentally is that if we just look at the speed, if it's migration, it's faster. If it's cultural learning, it's a slower process because it takes more time. And if you look at the package of the elements being transmitted, if it's complete, it's a proxy for migration. If it's partial, it's actually evidence of adoption. And this is a very nice paper by John Robb and Professor Miracle that actually criticize this one. There are other explanations that can lead to these exact same patterns. That said, there's been even attempts to try mathematical infer. This is probably the most, going really to the other extreme. This is a paper by Bucking Ford who claims that if the speed is between 0.03 to 0.66 kilometers per year, it's purely cultural. If it's between 0.68 to 1.48 kilometers, it's purely demic. And if it's 0.68 to 3.04, it's demi-cultural. If it goes above 3.04, it's not possible. So you go to that extreme on where you trust too much. And of course, all of this is not even taking into account the fact that speed itself has uncertainty because the data underlying this is uncertain. That said, that variation in speed does retain some information. There is reasons why there's delays. Might not be migration versus acculturation, might be simply local adaptation. There's variation. We don't reason on a plain landscape. Everything is different. So still, measuring the speed can provide an initial clue. So one thing I do agree on this literature and this research is that's the start point. Let's start by measuring the tempo of the dispersal. How do people do this? So typically, when you calculate the rate of dispersal, you run a regression model where you have a distance from a putative source. This is one example. And then you choose dates that are earliest evidence of farming from a particular area. So you take the median radiocarbon date, you run a regression analysis, and the slope gives you the years. This has a number of issues from a statistical point. Aside from, of course, you need this sort of source point. First, how do you select what's the earliest date in a particular region? What's the criteria? And many of these publications don't really provide you the criteria. They give you just a list of dates, but we don't know which one were included and which one were excluded. And second, particularly relevant in this case, is the problem of taking the median radiocarbon. So this is a simple, it's not even a simulation. Suppose the true arrival time of rice farming in 4 different regions are represented by these black dots. Right? So these are the true calendar dates. Somehow we magically know when it arrived. Now, imagine taking the radiocarbon date from that point in time, calibrate the date, take a median, and go back. That's the red dot. The reason, there's a plateau. So if you have a plateau, all dates along the plateau basically give you the same, more or less the same posterior distribution. And if you take the median, they give you a roughly the same. Now, the red line effectively is suggesting that there's almost an instantaneous spread of rice over 600 kilometers, while the black dot is saying that that's not the case. So calibration effect has a huge impact in calculating the speed. And so we need to account for that factor. I know it's just a statistical aspect, but it has a huge implication in terms of narrative that we might get at later on. So what we did for our project, we collected all radiocarbon dates on rice we could find. We looked at the site report. In many cases, it's reported as rice grain, but there's no photograph or the date itself is suspicious. So we try to check as much as we can from those dates, which are the ones that are sort of trustworthy. And we found many dates that were very suspicious and we excluded those. This doesn't mean that we didn't take into account, say, dates which has a large calibration error. That itself is not the problem. That adds uncertainty, but that's not the problem. The problem is when you don't have a photographic evidence or the date is completely out compared to the site. We consider it just a subset for this analysis of nearly 300 dates from 130 sites. It's large. I know it doesn't sound much, but considering the size of Japan, having that many direct dates from seeds on a particular crop is remarkable. And what we did was to develop a series of new Bayesian analysis, which I'll talk in briefly, that try to address many of these issues that I mentioned before. The data set, the script is all openly available. There is a publication that will come out next week on Science Advances. If you're interested on the nitty-gritty mathematical detail, those will be presented there. But I will skip the math today. I will show no equations. I will just talk about the main key points of why we use specific methods. So first we wanted to infer the local speed of dispersal. And so we come up with a method. It's a very fancy name, Bayesian Gaussian process quantile regression. Don't worry about the name. That's 3 bits of the name that address 3 different aspects of this problem. So it's Bayesian, so it's accounting for chronological uncertainty. It's using the full posterior of each state. Actually, it's very similar to how Oxcal works, if you're familiar with Oxcal. Gaussian process enable us to look at the spread from a local standpoint. So it's not just measuring this dispersal, overall dispersal rate, but it's actually measuring dispersal rate for each particular region. And quantile regression is a technique that has been already used for spread farming. It uses all the data available and then tries to fit the first percentage that you want to. So if you run a regression, the line goes through the mean. A quantile regression, the line goes through whatever quantile you're looking at. So if you use the first percent, the line goes through the first percent. So that's one way to address the problem of getting the earliest state. So we combine these techniques. It's a new technique. So what we wanted to do is whether it works. So we simulated on the top left a fake dispersal process with different local rates. And then we try to see whether the method works and whether we can reconstruct the speed. And the top left is the simulated one. The top right is basically the one predicted by the model. And it's not perfect, of course. And you see there's a bit of uncertainty, but it does capture the key geographic variation that we're in. So all the techniques we try to simulate to see whether it works. And of course, real world is even more complicated. But if it doesn't work in a simulated data set, it certainly wouldn't work with a real one. Then we try to estimate the arrival dates. Now, estimating the arrival dates can be done also with the previous technique, but there's better ways. What is typically done is to use models that are used for stratigraphic chronology. So you have 20 days from a particular stratum, and you try to assess when is the start point of that stratum. That technique can be used for regional analysis. So instead of a stratum, you pick up a region, you have all the dates of the region, and you try to estimate when is the start point of that region. The idea here is that if you have more samples, the earliest date will be closer to the true start point. If you have fewer samples, the earliest date can be potentially far away from that earliest date. We also account from sample independence. So one of the recent publications that employ these techniques didn't distinguish the fact that you might have 20 dates from 20 different sites, but you might have 20 dates from one site. If you have one site, you're dating the site, not the region. If you have 20 dates from 20 sites, maybe that's a region. So how to account for sample independence. So this is, again, a simulated data set. So the hierarchical model is the orange one that accounts for that sampling independence, and the true data fits into this. If you don't account for that, you might get misleading results. So this is, again, with simulated data to show that there's potentially results will give you a much narrower uncertainty when effectively there's more uncertainty because it's coming from this. Yes.
Can I ask you a question about the model that you use?
So this one or the
previous one?
Yeah.
So when you design this regression model, are you putting all these 3 processes into a single model simultaneously, or is it
it's a single model? Yes.
And then do you have, what kind of like sensitivity testing do you have to do to ensure that there's not an issue of overfitting or
so it's a hierarchical model. So overfitting is basically accounted for partial pooling. So what happened is that if you have fewer dates in a particular region, the pool of the local sample is much smaller because it's more likely that the general trend is more informative. Well, if you have lots of data in a particular region, you have more confidence. So there's much more pooling towards that local data. So it's very suited for a Bayesian approach because the prior effectively is everything else other than the sample you have informs the prior. So if I'm estimating a local dispersal rate on a particular region, I have information from the other regions partially to infer that particular region. If depending on variation in sample size, the pool of the local region will be stronger or weaker. So if you have an area where you have a small number of rates, your posterior for that region becomes much wider.
But then could there be a sampling error that comes from these prior, samples that you're using to infer data on successive samples for building a Bayesian model? Like if there's, for example, like low data, if you don't have a lot of data points for the first, I don't know, 5 to 10 sites.
So in terms of so of course, if the sampling is biased because I don't want to date a particular region, sure, yes, that's always a problem.
Yeah.
If the sampling issue is related to, say, the rate of adoption of farming is particularly slow in a particular region, so you have, let's say, you can imagine a situation where rice arrives, suddenly you have tons of dates, and a situation where rice arrives, the number of dates start to increase, but it's smaller. That's handled by the quantile regression. Because quantile regression doesn't use only the earliest date, use the full set. So the quantile of something that is large will be much, well, if you have a slow rate, you basically the quantile adjusts on that. So they are sort of pulling each other to some way. Of course, as you say, if there's a sampling bias, which, could well possibly happen because, say, certain regions you really believe there's rice, that's something that it will always, it's a curse that we have all the time for any legacy data. How people collect the data is not necessarily random. So I'm sure there's a bias towards early dates, but I don't expect that to be necessarily regionally specific. I think each region will try to get the earliest date. So the gambit here is that bias shouldn't have a geographic pattern. I might be wrong, but that's the best I can do at this stage. But the model is basically everything happens at the same time. It's a single model. It takes 3 days to fit the model because of that. And that's the curse of being Bayesian. Right. So let me go to briefly discuss the results. So this is the posterior median. I won't show you all the posterior for each region. The model basically has one parameter that basically deviates from the general trend. And this is this parameter S. So the easy way to interpret this is that when S is red, you have faster rate. When S is blue, when S is negative, you have a slower rate of dispersal. So the way to interpret this is whenever you see blue dots, that region was particularly slow in the dispersal rate. And whenever you see a red dot, it's relatively fast. The scale of this autocorrelation is again inferred from the data set. The right plot is probably easier to interpret. This is just a row average dispersal rate. Right? So blue is between 0 and 1, towards red is extremely fast, maybe 4 kilometers per year. And just to give you a frame of reference, the average dispersal rate of rice farming in Europe is about 1 kilometer per year. If you look at regional variation, you see up to, you see the publication earlier, above 3 is impossible, but we see variation up to around 3 to actually, you can see 4 kilometers per year. And just to give you an idea on where this happens, if you're familiar with European analytics, there's a slowdown in Denmark that goes below 1. Faster regions like LBK, you have a faster rate. And all of that is sort of, in a sort of miniature version, you can see this happening in Japan. The difference, I'm not showing that, so it's fine. If you even simplify this, what you have is basically 2 major regions where spread of farming is relatively slow. One is in Kyushu, where rice farming first appears, and the other one is in the Tohoku region. With an exception on northern Tohoku, I'll come back to this why that northern bit is actually faster. And the fastest adoption happening in that area that I showed earlier that was represented by the central culture. Right? I'll go through first the result and I'll discuss this. Then we did the regional analysis. What we tried to do, one of the problem of doing the regional analysis is how you define your regions. Because of course, if you change your region size, your result will change. And there's no right answer for this. Any choice would be wrong, right? You can try to choose an ecologically homogeneous zone, but that's assuming a priori that ecology is basically having a certain kind of impact. So what we did was actually use the dispersal rates to try to characterize, to try to inform a bit of this model. Of course, there are some other distinctions, like northern Kyushu is renowned archaeologically to be distinct, so we separated this. And we did 2 models, one where we just used the dates to infer the arrival time. So for each region, we just use the dates of that region, that's representing the start point. The second model, model B, is using partial information we have archaeologically in terms of order of occupation. So we know rice arrived in northern Kyushu, so that must be earlier than, say, region 2 and region 3. We know there is generally sort of a wave of advanced dispersal until central Japan. So 3 happens after 4 and 5 happens after 4. After that, it's a bit of a mystery. If you look at the literature, people suggest different routes. There's ideas of possible leapfrog, expansion from north to south or south to north. So what we did was, for the latter half, the only thing we know is it's after 4, but what happened from 5, 6, 7, 8, we let the data speak itself. Right? So it's a sort of a partially constrained model that enables you to provide a narrower chronology, but of course the expense that you're putting in an assumption. And this is not stratigraphy, right? This is assumption that is based on, you can't disagree with me and say, well, that assumption is incorrect or etc. And this is the posterior we get on the two models. And as you can see, if you put a constraint, your posterior becomes much narrower. For example, northern Japan up there, region 8, much uncertainty because it's a relatively tiny region, you have fewer number of dates. But of course, if you add a constraint, that narrows down the posterior. And let me examine bit by bit what's happening. It's a bit of a cheating, but so you have rice farming arriving a bit earlier than what is suggested. Makes sense because this is a Bayesian model, so it's accounting for the fact that early state is not there. That said, there's a recent publication that is looking at inclusion in pottery, and we're getting earlier and earlier dates. So I'm convinced that it's not 9th century, it's probably earlier, and that's the median posterior we get. We have a first interesting delay. Rice seems to go much quicker towards west rather than south in Kyushu. So the rest of Kyushu, the arrival time is 570 BC. There's a delay of several few centuries, and rice actually moves much quicker towards west in the Chugoku region. So that's our first major slowdown. Then we have a fairly quick expansion in central Japan, and then we have a second slowdown, not as big as the first one, but appearing right at what is, I think Gina Barnes called it the waist of Japan, roughly where you have the transition between East and Western Japan. You have a second slowdown. Not as big as we were expecting. We initially expected that to be the major point of delay, and it doesn't seem to be the case. There is a delay, but that's not the major one. And then we have a bigger one, actually, from there onwards. And we have two interesting things. First is that early dates on the top. And this is an interesting case of early rice farming arriving in northern Japan. And this is not just rice grains that might be, exchanged. You actually find paddy fields. So somehow rice farming leapfrogs to northern Japan. Some authors suggest that they might actually go through a coastal route, but there's not enough dates to actually support that. We don't know this. It's a speculation. So we don't know whether it's a coastal route with a very low population size, we simply didn't detect enough sites, or whether there's actual leapfrog to northern Japan. That said, there is clear evidence of, I think there's more than there's 3 at least paddy field sites dated to that period. In fact, that represents the start of the Yayoi period in northern Japan. Interestingly, that rice paddy fields get abandoned after a few centuries, and there's a reversion to hunting and gathering. So it's a temporary adoption of rice farming that gets abandoned. There's other interesting things like toolkits associated with those paddy fields are actually different. So there is a very typical stone sickle that you find in the rest of Japan, but instead in northern Japan, in Tohoku, you don't find those sickles. They seem to carry on using toolkits from the Jomon period. So there's clearly something different going on in there. And the other major delay is actually somewhere between Chubu and Kanto. This is actually, Kanagawa actually has some early dates, so it's not really Kanto itself, but you see a major slowdown of a few hundred years from Chubu to Kanto. Right, so why? What's going on, right? So I don't have an answer. We're doing a whole project to try to understand this, and part of the first stage, we measure if there's a variation. Second stage is to test various variables, and of course, we now moving to that stage. So everything from here onward are speculation. We're collecting data, but I just wanted to share my idea and hopefully have some ideas from the audience in terms of other possible explanation. First possible reason is temperature constraint, right? So the rice arriving in Japan, actually there's discussions about what is the exact variety. Some people are saying that the earliest first rice in Japan is actually not the temperate japonica, but actually a tropical variant of japonica. And then subsequently, you have a temperate japonica coming in. But there are, of course, climatic constraints about whether you can grow rice or not. There's a paper by J. Del Poinguedes that applied to other parts of Asia, mainly the Shandong Peninsula, and one of my PhD students is actually trying to apply that model into Japan. What is interesting is that preliminary results are suggesting that you need to have transplanting, otherwise the climatic constraints is too hard. So we're doing now a model that accounts for transplanting. That said, clearly there is an impact, especially if you go to northern Japan. It is colder, so there is a question whether rice is as sustainable as with specifically the ancient variety that were available. She's also trying to use experimental data from varieties that are not modern, because of course modern rice are, you have rice growing in northern Japan now, even Hokkaido, they're very good, but of course they are adapted to and they are sort of hybrid rice. Another possible explanation is soil. This is a map showing present-day Japan, which smallest administrative unit has rice farming as the predominant model. So it's simply looking at percentage of land used for different type of crops. And the ones in black, excluding Tokyo, I think Tokyo is not included in analysis. The ones in black are the one where the area dedicated to rice is the largest, right? So it's simply the largest. It might, be just larger than something else, but it gives you a sense of where rice is being grown currently in Japan, accounting also from urbanization. And you see that there are certain regions that are white. Basically, there's no rice farm. One possible explanation for this is the type of soil. Right? There's various reasons why certain kind of soils are more or less adapted to the growth of rice. One possible hypothesis is andosol, which is volcanic soil. Particular type of andosol called allophonic doesn't retain phosphate. Actually, it keeps phosphate, doesn't give it to rice, and that seems to be not particularly suitable. So in these regions, actually, people put artificially phosphate so that rice can grow. There's other explanation related to aluminum content. Apparently, Japanese japonica is particularly adapted to aluminum, and that might be actually a consequence of historical rice production. But it is interesting to see that those big measures today seem to be matching with allophonic andosol. It might be pure coincidence. We want to, of course, explore more because there are various types of andosol as well, so they're not just two types. But it is one possible explanation why we see the major decline happening at those two regions. There's others. Another reason might be simply the fact that you have Japan is a highly mountainous country. You can imagine Japan as being, especially from a rice farming perspective, almost as if there's a tiny little patch where you can grow rice, and then you have mountains in the middle. So those mountains would, of course, impede not only the contact, but also you cannot just grow to the next neighborhood. You have to move quite far away. The biggest decline, one of the big slowdowns happened right here, just when you start to approach the Japanese Alps. This is a cool picture. I think it really looks like a wall. So that might have an impact. Same applies for Kyushu. Once you go south of northern Kyushu, you actually have a mountainous region. So that might be itself, you have to choose. Are you going south? There are mountains, so it doesn't seem to work. This way it's working. You go first. So I don't want to say this all ideal free distribution kind of scenario, but the order of occupation seems to follow that. Related to this, to the mountain region, is also whether the pre-existing social network had some role in the spread of farming, right? So you're not moving into an empty land. There are people living there. It's very likely, I don't believe in pure demic diffusion doesn't make sense in Japan, because pure demic diffusion means somebody's moving in, there's no admixture, it's an empty land. That's not the case. There are incumbent population. Pure cultural diffusion implies that there's no admixture. You just copy the subsistence strategy. There's no interbreeding. That, of course, is not the case. We know this for a fact. So clearly there's admixture. Clearly there is contact. There's marriage networks that play a role on where you move. And so one possibility is that they are moving to different marriage network as inferred from different pottery zone might be actually one of the reasons where there's a delay. This is a map actually overlaying all the pottery zone of all Jomon periods, and one of the big boundaries happen to be right at the waist of Japan. This is actually in the early Yayoi, initially Yayoi, the different pottery zones, and you see actually transitions. There's a pottery style known as Totaimon stops roughly there. So the crossing of Totaimon to new pottery zone might actually be possibly moving into a different social network. We don't know, we cannot prove this, but it is a possibility of so whether it's the mountains or the social network or both, it's an interesting speculation. That east-west divide, incidentally, it's something that you see even across the Japanese period. This is more for fun, but this is rice. Different types of mochi in Japan. Eastern Japan, you have square mochi and you grill them because they taste much better that way. And from Eastern Japan, Western Japan, you have round type of mochi. You sort of you make some sort of stews, and that boundary also happens to be roughly around there. There's other interesting possible boundaries between East and West. I mean, that's another dichotomy that is very common in Japan from a culture standpoint. I'm not saying that this is the reason, mind you. There are historical other reasons that might explain this, but this East and West divide is something that is common. Another thing, I didn't really have much time to speak about millets, but I think it's important to acknowledge millets. We don't have that many dates on millets, unfortunately. While we have nearly 400 dates on rice, millets, foxtail, and broomful together is less than 10. So doing something similar with millet is basically impossible, is the date available. That said, there is a rich tradition of studies on seed impressions on pottery. And that seems to suggest, so these are maps of different periods, and red is basically millet, green is rice, red and green is basically impressions of rice and millet. What you see in central Japan is there seems to be evidence that millet actually appears earlier than rice. So we need to account for what is the relationship between millet farming and rice farming, whether they spread together or millet farming actually create a different sort of a sensitivity to farming itself, or rice farming itself. The problem, of course, is that this is based on seed impressions on pottery, and as I said earlier, pottery chronology is tricky. So it's hard to disentangle the absolute chronology and the offset between them. If we believe, though, in terms of relative sequence, in Kanto we see millet in earlier pottery style compared to rice. How much early? That's the tricky aspect that we're looking at. There's other interesting elements of other kind of farming having an impact. Soybean, I'll speak about it tomorrow, has an expansion, and Kyushu has actually evidence of soybean cultivation increasing right before the arrival of rice farming. So there is an idea of whether that sort of know-how facilitated the adoption of farming. There is also potential impact related to I don't have any picture of incumbent population sizes. So Eastern Japan had a higher population size. There is a much stronger reliance on, there's one slide that somehow went missing. You have to imagine a map of Japan with bubbles, and bubbles are larger in Eastern Japan, and it's a proportion of toolkit related to fishing. And there's an old paper by Kazawa Takeru who suggests that certain fishing was an alternative subsistence strategy that basically led to the resistance of local incumbent hunter-gatherer groups. Let me look at consequences since we discussed briefly population size. So this is, again, pure speculation, but it's an interesting these are two papers, both trying to assess the effective population size from genetic data of history of Japan, right? One is using mitochondrial DNA, and the other one is using Y chromosome. And what's interesting is that you see this drop in Y chromosome, but you don't see this in the mitochondrial DNA. And I'm not a geneticist, so bear with me. But there is interesting speculations about this phenomena appearing in other parts of the world, where you see this sort of decline happening only on Y chromosome, but not on mitochondrial DNA. And one possible reason, so what happened is that effective population size is not census population size, it's the number of parents people have giving offspring. If you have a drop in Y chromosome, means that you have fewer male parents. So that means that fewer male individuals had more offspring, contributed more compared to the other situations. So that might be possibly related to different kind of marriage system being introduced in the early period. So it might be a patriarchal system where you have polygamy, for example. That might actually generate that kind of pattern. And there's interesting speculations about how how big was the size of the migrant communities in the Japanese archipelago, who was driving this transmission, whether it's incumbent hunter-gatherers adopting and being the driver of adoption, or whether it's the migrant communities pushing this. And a lot of this discussion boils down to how many people and how much they had an impact. And one of the criticism about possible large migration is basically derived from the archaeological record and the fact that there is pottery style that are more Jomon predominant, so it might have a fewer small influence. But you can imagine easily an explanation where you have a sexual division on labor. If pottery were, say, made by women, and there is a pottery local system, you would have a mixture of those two elements that are explained purely by changing marriage system. So it is speculative. It's hard to, of course, disentangle this, but the impact of marriage system in explaining part of the archaeological record in this case, and the discrepancy we find between certain elements is something that might be related to this element. In terms of local response, this is actually based on site settlement data. We are working on the radiocarbon dates, but you can see the black arrow is the median arrival time. The dashed line here is the estimated arrival time for each area. The gray sort of envelope is the uncertainty in the arrival time, and the black arrow, this is pure eyeballing. It's me saying, oh, that's the point where you see first big growth. And what happened is, of course, that the growth happens later, but there is an interesting discrepancy on whether there is a delay between the population increase or whether it's so. Area 6, which is Kanto, we almost see immediately rice arrives, population goes up. While in other regions like Kyushu, rice is there for a few centuries before we actually see a genuine population increase. Now, this is purely based on eyeballing, but for Kyushu, we actually try to collect the radiocarbon dates and try to estimate if there is a change point. So we fitted the model that we fitted various model, one that is simply exponential, because exponential would also give you a similar curve, and one which is a double exponential with a change point. So there's a point in time where growth rate changes. And we were interested to see whether that change point, how does that relate to the arrival rice farming? Is it coinciding with the arrival rice farming, or is there any delay between the change point and the arrival rice farming? What we see here, actually in the paper, we didn't have the arrival time, so this is different from what you see in the paper. We see that there's an approximate delay of nearly 300 years before you actually see a population increase. Why is this the case? One thing that we need to factor in is that there's not single migration. There might be multiple migration. And Kazuo Miyamoto from University of Kyushu suggests that actually there's two big waves of migration. The first one, which didn't really introduce rice farming, possibly related to tropical japonica. A bit controversial. The DNA is not much successful, not much a major impact. It stayed there, but it really made changes. Then you have a second wave, which is the one that coincides actually from that major population increase. This time is temperate japonica, possibly. And you actually have other elements, most notably different pottery style that is, so that's a pottery that is very typical of Yayoi happening there. So it might be the first migration really set the ground, but didn't have any impact. The second one is what actually pushed and led also to dispersal of rice farming in the rest of Japan. So just to summarize what the kind of results we get. So clearly there's variation across Japan in adoption and farming. That's undeniable, and I think it supports all the argument that has been made based on other kinds of evidence. We see this also, even if we restrict our sample size to something that has a better accuracy and precision, we still get that result, which is good. In Western Japan, we generally see faster rate, up to 4 kilometers per year, which is very fast compared to other parts of the world, with exception of what happens in Kyushu, where there's this delay from northern Kyushu to southern Kyushu. Soil condition seems to be the most, the strongest, reason why we see this. Certainly it's not temperature variation. Even nowadays, there's not much rice paddy field in southern Kyushu, so that might be a possible reason. As I said in the previous slide, there seems to be a temporal offset between the population increase that might be related to different episodes of migration. Central Japan, we see a slowdown. That's not, this goes against, there is an interesting paper by Kobayashi Seiji who suggests there's multiple Jomon walls that are local area of resistance and he puts the biggest wall in the waste of Japan. That doesn't seem to be the case, although the type of rice farming that crosses and reaches Chubu is probably different. There's speculation whether that's actually dry rice farming, because we don't find actually paddy fields. If you read different authors, some suggest that it's wet rice farming, it's simply the location of paddy field is different, so it's not necessarily close to the settlement, and that might be the reason. Others suggest actually dry rice farming. There are attempts to try to distinguish one from the other from the isotope, but it's still open question. So it might be a different form of rice farming that is actually linked to millet cultivation that seems to appear earlier. But certainly, we don't see that delay. There are multiple sites with radiocarbon dates on rice that is arriving fairly early. While we see a big delay in Kanto, and this is undeniable. And in Kanto, actually, once rice arrives, you start to find paddy fields. So it is actually a genuine delay we see across different ethnics. Northeast Japan, there is delay. It's undeniable. We have also much smaller population sizes even after the arrival of farming. If you notice the y-axis on the previous plot, it's much, much smaller. And it's smaller until much, much later. So clearly, there's no demographic consequences. There is an interesting episode of attempted adoption of rice farming. And I think it's a great example of reversion to hunting and gathering economy. We don't find millet there. We find barley and millet, but that's a separate story. We don't find foxtail, broomcorn, millet, and we see this interesting case of reversion. And possible movement southward in Sendai, where we see other sites. There's also an interesting idea about location. So if in central Japan, we don't find paddy field, but we find settlements, those paddy field sites, we don't find pit houses. We find only the paddy field, but we don't find the houses. So there's clearly also a different relationship between settlement area and paddy field area. So what's happening in northern Japan is also its distinct story. So that's all from me. Well, thank you for listening. Thank you to my team who helped me a lot in many things, and also the collaborators in Japan who gave me so many insights and suggestions to this work. Thank you.